Hey everyone, welcome back to TechOps tutorial. In this video, we are going to talk about Kubernetes DaemonSets, what they are, why we use them, and I will show you a quick demo. DaemonSets are used when you want to run a pod on every node in your cluster. For example, if you have a tools for logging, monitoring, or networking, you usually want them to run on all worker nodes, not just one, and that's exactly where the DaemonSets help. Here on the slide you can see 3 worker nodes each running one DaemonSets pod. That is its main purpose. No matter how many nodes you add or remove, Kubernetes ensure there is exactly one pod from the DaemonSets on each node. Before we talk about DaemonSets, let's quickly recap deployments and replica sets. Deployments are great when you want to manage the total number of pods in your application. They also distribute pods across the cluster, but they don't ensure one pod per node. If you look at this example, our cluster has 4 worker nodes, but the pods are not evenly spread. You can see node 1 and node 2 have a multiple pods, while the node 3 has none, and node 4 has just one pod. This is normal behavior for deployments and replica sets. They only make sure the total number of pods is running, not how those pods are spread across the nodes. So, how do we make sure there is one pod running on every node? For that, we need a different Kubernetes resource, and that's what we explore next. That is DaemonSets. Now that we have covered deployments and replica set, let's dive into a DaemonSets. A DaemonSets is a Kubernetes resource that ensures there is exactly one pod running on every node in your cluster. Think of it like this. This pod must live everywhere. Let me explain how it works with a simple example. Let's say we have a Kubernetes cluster with 2 worker nodes. On worker node 1 and worker node 2, there is a pod running from the DaemonSets. Now, if a new node joins the cluster, Kubernetes will automatically create a pod on that new node too. So now, every node in the cluster has one DaemonSets pod running. But that's not all. If a node is removed or become permanently unready, like node 4, the pod on that node will automatically cleaned up and removed. In short, a DaemonSets ensures that there is exactly one pod on each node, whether nodes are added or removed. The DaemonSets automatically adjusts. That's the key idea. Exactly one DaemonSets pod runs on every node. Now let's take a closer look at some of its key features. One pod per node. Auto adjust node restriction. The first feature is one pod per node. This guarantees that there will always be exactly one instance of a pod running on each qualifying node in your cluster. It's simple but powerful concept. Every node gets a DaemonSets pod, no exceptions. For example, if your cluster has 5 worker nodes, you will always have 5 DaemonSets pods running, one on each node. Second, auto adjust. DaemonSets are self-healing, which means they automatically respond to changes in your cluster. If a new node joins, a pod is automatically created for it. If a node is removed, the corresponding DaemonSets pod is deleted. This ensures that your cluster's desired state is always maintained, no matter what changes happen. It's like Kubernetes is always keeping everything in check for you. Next is node restriction. DaemonSets can be configured to target specific nodes in your cluster. There are few ways to do this. Node selector. This allows you to match nodes by their label, making it easy to select specific nodes. Next is toleration. You can configure your DaemonSets to run on tenant nodes, those nodes that have been marked to prevent certain workloads from running. Affinity. This is for a complex node selection rule, helping you specify exactly where your DaemonSet pod should run. With these features, DaemonSets give you full flexibility over how and where your pod run in your cluster. So, in short, DaemonSet ensure one pod per node automatically adjust when nodes are added or removed and allow you to target the specific node based on labels, toleration or affinity. Simple yet powerful. Next. So far we have learned what DaemonSets are and how they work, but now let's talk about why we actually need them. There are some workloads that must run on all nodes in your cluster for things to work properly, and that's exactly where DaemonSet comes in. Let's go through some common use cases. First is log collection. If you want to collect the logs from every node in your cluster, like system logs or container logs, you need something running on each node to gather them. DaemonSet make that easy by automatically placing a logging pods on every node. Next is monitoring. To track things like CPU, memory, disk usage on all nodes, you need a monitoring agent running everywhere. Again, DaemonSet help by ensuring each node has a pod collecting performance matrix. The next is networking. Some networking tools or services like network plugins or proxies need to run on every node to enable proper communication between the pods. A DaemonSet makes sure those components are present and running on all nodes. And finally, the storage daemon. If you are using a system that needs to manage storage at a node level, like attaching volumes or syncing files, you will want a storage agent running on each node. DaemonSet ensure that is taken care of automatically. So in short, DaemonSet are used for node level tasks, things like login, monitoring, networking and storage that must run on every node to keep your cluster running smoothly. That's why DaemonSet are such a crucial part of Kubernetes. Now that we have seen how DaemonSet work, let's look at some real-world example of tools that actually use them, such as logging tools. In Kubernetes, logging tools are used to collect the logs from every node in your cluster. That's why we can monitor what's happening across the entire system. Let's take a look at three popular logging tools: FluentD, FileBit and Logstash. First is FluentD. FluentD is an open source log collector and processor. It collects the logs from all the nodes and sends them to a log database. Since it runs as a DaemonSet, there is one FluentD pod running on each node, collecting the logs locally and forwarding them to a central place. Next is FileBit. FileBit is a lightweight log shipper developed by Elastic. Just like FluentD, it runs as a DaemonSet. So again, one pod per node. It reads the log and sends them to a Elasticsearch, which is great for searching and analyzing the logs. And then we have a Logstash. Logstash is a bit more advanced. It does not just collect the logs, it can process and transform them before sending them out. Like the others, Logstash also runs as a DaemonSet to make sure every node is covered. So in short, FluentD, FileBit and Logstash all run on every node using a DaemonSet. This setup ensures that logs are collected from the entire cluster, no matter how many nodes you have or how often they change. That's how logging tools use DaemonSet in the real world. Next. Now that we have seen how logging tools use DaemonSet, let's move on to our monitoring tools. Monitoring tools help us to keep an eye on health and performance of our Kubernetes cluster, just like logging tools we talked about earlier. These also run as DaemonSet, which means there is one monitoring pod on every node. Let's take a look at two popular ones, Prometheus Node Exporter and Datadog Agent. First is Prometheus Node Exporter. This tool collects the hardware and operating system metrics from each node. It gathers the information like CPU usage, memory usage, disk stats, and network traffic. Since it's deployed as a daemon set, it runs on every node in the cluster and sends this data to a Prometheus for monitoring and visualizing. Next is Datadog Agent. Datadog Agent collects even more, not just metrics but also event and traces. It helps team to track the application performance, detects the issue earlier, and even set up alerts when something goes wrong. And again, it runs as a daemon set, one agent per node, so it can monitor everything that's happening across the entire cluster. So in short, both of these tools are deployed as a daemon set and they collect the valuable monitoring data from every node, whether it's system level metrics with Node Exporter or full observability with Datadog. These tools are essential for keeping your cluster healthy. Now let's talk about networking tools, another category where daemon set plays an important role. In Kubernetes, networking and system tool often run as daemon set to make sure every node can communicate properly with the rest of the cluster. Let's look at two key examples, kubeproxy and CNI plugin. First, kubeproxy. Kubeproxy is a network proxy that runs on every node. Its job is to maintain the network rules that allows the service to talk to pod no matter where they are running in the cluster. By using daemon set, Kubernetes ensures that the kubeproxy is always running on each node, keeping the networking consistent and reliable. The next is CNI plugin. CNI stands for Container Network Interface. These plugins handle pod-to-pod networking and apply the network policies. Tools like Calico, Flannel, and Wave are examples of CNI plugins. Just like kubeproxy, they run as a daemon set to make sure every node has the right networking setup, allowing pods to communicate securely and efficiently. So in short, kubeproxy and CNI plugin are essential for networking in Kubernetes and both run as daemon set to ensure every node can connect and follow the same rule. Next, let's look at the difference between deployments and daemon set in Kubernetes. A deployment runs a set number of pods across the cluster. For example, here we have 5 pods and they are placed randomly on different nodes. It scales horizontally, you can add more pods as needed, and you can control the total replica count. But one issue is that pods may not be evenly spread across all nodes. Now, a daemon set works differently. It makes sure there is one pod on every node. So if you have 3 nodes, you will get 3 pods, one per node. As new nodes joins the cluster, daemon set automatically adds pod to them. This makes it perfect for node level service like monitoring or logging. So in short, a deployment controls the number of replicas and the daemon set guarantees one pod per node. Next. Now let's see how a daemon set works internally in the Kubernetes. A daemon set controller consistently watches all the nodes in your cluster. Whenever a new node is added, it automatically creates a pod for that node. If a node goes down, it removes the pod from that node. This process goes through the API server, which stores the current state of all pod and nodes in the etcd. Next, the scheduler steps in. It decides which node should get the pod based on node selector and available resource. So, for healthy nodes, the pod keeps running. If any node fails, pod is terminated, and when a new node joins, a new pod is created automatically. This forms a continuous feedback loop where the controller keeps monitoring node changes and ensures that there is always one pod per node in the cluster That's how DaemonSet maintains perfect coverage automatically and continuously. Alright, now that we have know what DaemonSet do, let's see how actually create one in Kubernetes. Here on the left, we have got a sample YAML file for a DaemonSet called node monitoring. This YAML basically tells Kubernetes, hey, I want one pod running on every node in the cluster. Let me quickly break it down. The kind is set to DaemonSet, which is how Kubernetes know what we are creating. Under metadata, we give it a name. Then under spec, we define the labels and the template for the pod. These labels match and schedule the right pod to the right nodes. Once the YAML is ready, all we need to do is apply it using the command kubectl apply-f daemonset.yaml. Then we can check if it was created with kubectl get daemonset, and to see where the pod are running, we will use kubectl get pods -o void. Now here is the cool part. You will see one pod on each node automatically. On the bottom you can see the simple visual. Node 1, node 2, node 3 each has one DaemonSet pod running. That's exactly how it should work. So now that we have covered the YAML and the commands, next I will switch over to a terminal and show you all of this in action. Let me access the terminal. I have already started the Minikube. Let's check the status. They are running. Let's start by creating a DaemonSet YAML. We will run nginx on every node in the cluster. I will create nginx YAML API version apps v1. DaemonSet metadata name nginx DaemonSet namespace. Will not give any namespace. If you want, you can provide the namespace, or for now I will give default ult default. Spec selector match labels app nginx daemonset. Template metadata labels app will provide the containers, give the name and provide the image nginx latest ports 80. Default kubectl apply -f nginx.yaml kind does not match. DaemonSet labels DaemonSet is created. Now let's verify. kubectl get DaemonSet. Output shows nginx-daemonset with a desired current and ready equals to number of nodes. We can see the DaemonSet created and it automatically ensures one pod per node. Let's check the pod running from its DaemonSet. If single node, Minikube, only one pod. If multi-node cluster, one pod per node. Node column shows the different nodes. Notice that each node is running exactly one pod from our DaemonSet. Now let's verify these pods are indeed managed by the DaemonSet. kubectl describe pod. You can get the pod name. kubectl describe pod name. You can grep -i controlled by. So this displays controlled by DaemonSet / nginx-daemonset. This confirms that the DaemonSet controller manages these pods, not a deployment. To see how DaemonSet behaves when a new node are added, we can scale our Minikube cluster. Minikube start -nodes equals to 2. This will take some time. I will pause the video, and once this is done I will resume back. Now check kubectl get pods -o wide. kubectl get nodes. I already had a Minikube cluster running with one node. Then I tried with this command to add another node, that is Minikube start -nodes equals to 2, but it did not work as expected. Only one node we are able to see here, that is Minikube. This is because the Minikube start does not add a nodes to an existing cluster. Let's see if this works. I will pause the video. Once this get created, I will resume back. We are not able to add one more node in Minikube. So let's try to delete it and recreate once again. I will try to Minikube delete, and we will create once again with Minikube start -node equals to 2. Here it shows Minikube -m02, but here it has not shown. Equals to 2. Minikube start -nodes. Let's give a try if this works. See on my screen, you can see Minikube M02, another node is getting created. kubectl get pods. So here you can see we have the two nodes Minikube and Minikube-M02. Since I deleted and recreated Minikube, all old resources were wiped. So let's recreate the DaemonSet YAML file again. kubectl apply -f nginx.yaml. Now check kubectl get pods -o white. As soon as the new node join, Kubernetes automatically schedules the another nginx pod on that node. We don't have to do anything manually. DaemonSet handles it for us. Now let's delete one of the pod and see what happens. kubectl delete pod. This is taking time to delete, so let's wait. So the pod is deleted. Recheck. So here you can see it is creating the pod 5 seconds ago. The pod was recreated automatically on that same node. This proves that the DaemonSet maintain one pod per node at all times. Finally, let's clean up our DaemonSet. kubectl delete -f nginx-YAML. kubectl get pods. There is no any pods. All nginx pods are gone. The DaemonSet and its pods have been completely removed. So let's recap. To summarize, a DaemonSet ensures one pod per node. It automatically adds pod when the new nodes join, and if any pod is deleted, it's recreate automatically. That's the power of DaemonSet in Kubernetes. Simple, self-healing, and perfect for node level tasks. If you found this demo helpful, don't forget to like, subscribe, and hit the bell icon for more Kubernetes tutorials. Thanks for watching, and I will see you in the next one.